Hi viewers, in today's video we'll be talking about the quotient rule. In the last video we spoke about the product rule. So when do we talk about quotient? When we say two things are quotient of each other, it means they are dividing each other. So quotient rule right now is talking about two functions dividing themselves. So quotient rule is in the form y is equals u over v, where u is a function of x, v is a function of x as well. Just like we spoke about that in that of product rule in the last video. So for this one, we'll be using same method. We'll be using the logarithmic differentiation as well to solve for the quotient rule. So let's get down to business. So the first thing I'll do is, recall from the last video we said we take the natural log of both sides. So it's going to be ln y is equals ln, we put this u over v, just like we did in the last video. So this right now, from the properties of logarithm again, when it was product, we said we add them individually. So right now, when it's dividing itself, like u over v, you subtract. When it's division, you subtract. When it's multiplication, you add. So right now, it's same thing as saying ln y is equals ln u minus, because it's division, so minus ln v. So at least you can see that we've reached that in the last thing we did in the last video. So differentiating ln x, like I said recently, I said ln x divided x of ln x is 1 over x. So same thing will be happening here again. The derivative of ln y is going to be 1 over y dy dx, and this is equals derivative of ln u is going to be 1 over u du dx minus derivative of ln v is going to be 1 over v dv dx. So same thing, we need dy dx, not 1 over y, dy dx. So what do we do next? We multiply both sides by y. So I'm going to have y times 1 over y dy dx is equals y multiplied by the whole function here, which is 1 over u du dx minus 1 over v dv dx. Sorry, dx. So right now, you know, y, we cancel y. So we have dy dx. We're going to have dy over dx is equals, in place of y, I'll be putting u over v, because that's what we started with u over v. So something we'll be using here. So in place of this y, I'm putting u over v, open bracket, I'm bringing the whole thing in the bracket. So I'm having 1 over u du dx minus 1 over v dv dx, close bracket. So right now we can expand the bracket. So I'm going to have dy dx is equals u over v times 1 over u du dx is going to be u times 1, we have u over v times u, I'm having vu, then I'm bringing my du dx. You should take note of how I expanded this. Then this is minus u over v times 1 over v. I'm going to have u times 1, which is u, over v times v, which is v squared. I'm bringing my dv dx. So from this point, you can observe very well that u cancels u. So I'm having dy dx is equals, what is left here is 1 over v, and I'm having du dx minus u over v squared dv dx. So right now, if you observe, we have v in the denominator, we have v squared in the denominator. That means the LCM of v and v squared is what? V squared. You pick the highest power. So we are having dy dx is going to be the LCM, which is v squared, with a line. V into v squared is going to be v. V times 1, I'm having v multiplied by what? Du dx. I'm having minus v squared to v squared, that's 1. So 1 times u is going to be u, then bring your dv over dx. And with this, I think that's the formula for the quotient.